Hilda and I have been working on the idea of urine diversion for 15, 20 years. And the problem with the Cape, of course, is the urine and the nitrogen that is put into the ground from the septic systems, goes through the groundwater, and it seeps out through all the freshwater ponds, and it goes out into the ocean waters. And this green color you see all around the Cape, that's algae growing from the nutrients and the nitrogen that's seeping out from all sides of the Cape. This is Falmouth. This is our town. This is the nitrogen seeping out of the edges of the town, and the estuaries on the edge of the water are dark green from algae growing from the nitrogen that's going into it from all the houses. So what we've learned is that the nitrogen, that's the problem, is basically mostly coming from the urine that people produce and that's going into the septic tanks. And the urine from a person has 80% of the nitrogen that is going into the waste stream, the largest amount. But it's only 1% of the volume. So if you can deal with that 1% of the volume, keep it from going into the groundwater, do something else with it, practical, useful, safe, you've solved the problem. And if you do this on the Cape-wide basis, it's quite likely that you do not have to do anything else or build sewers. This is how the Cape works. In a watershed, you have houses, and each house has a septic tank, and all the urine goes into each septic tank, and it leaches out. The nitrogen goes right through, out the bottom, and it goes into the groundwater, and it slowly moves toward the ocean. And as it moves toward the ocean, sometimes it passes through a freshwater pond. When it passes through the freshwater pond, it can cause algae to grow, it can cause cyanobacteria to grow, it pollutes the pond. The water goes right on through, keeps going into the groundwater again, goes off to the ocean, and it pollutes the estuary in the ocean. So that's the ecological situation that the Cape has. Every watershed is like this. Now, if it goes through the freshwater pond, it can cause cyanobacteria. If it goes on the edges of a estuary, it can kill the fish from the waste algae and lack of oxygen. And eventually it goes into the ocean. And all the nitrogen and nutrients that are going from the groundwater into the ocean pollutes the ocean. And over the whole world, this is happening on all the coastal areas, and it produces red tides, which are toxic versions of cyanobacteria, all over the world. Most of the nutrients from most of the food eaten from most of the people in the world end up in the ocean. None of it goes back to the farmers where the food came from. Now, to remove it, the standard solution, which you saw in this conference, is to build a sewer. And a sewer is an extremely expensive machine, big installation that takes the wastewater and it gases off some of the nitrogen from the wastewater. It doesn't do anything else. It does not clean the water. It simply removes nitrogen from the water and puts the water back in the ground again or into the ocean. And it's extremely expensive to do this. The cost of a sewer to remove 1 pound of nitrogen is $300. A person makes 8 pounds of nitrogen a year. $2,400 a year it costs to run out through a sewer and deal with those 8 pounds of nitrogen. Urine diversion is an alternative where you take the urine and don't put it in the ground. You collect it or divert it, and it only costs 1/10 as much to manage the same pound of nitrogen with urine diversion as it does with sewers or IAs. So the economics of urine diversion compared to sewers and IAs is extremely good.
In that number that was just mentioned, where it's 1/10 of the cost, it doesn't include the advantage of not buying the water that you do not use for flushing or getting the fertilizer that you get from the nutrients that you're reclaiming. So that's not included. So if you included that, it'd probably is even less expensive.
Also, most urine diverting fixtures are waterless. And if you don't flush the urine in a house 6 times a day, a person saves 4,000 gallons of water. This is water the town has to produce and the person has to buy. So the cost of the savings of wastewater or water supply and fresh water is a big advantage of waterless fixtures for urine diversion. Now, the standard American solution for how we produce our food and dispose of the waste is to produce the fertilizer in a factory somewhere using natural gas, growing food in a field far away from the consumer, trucking it to the consumer eats it, all the nutrients goes into a sewer or a septic tank, and if it goes to a sewer, it uses large amounts of energy and wastes all the nutrients into the groundwater or into a sludge which is incinerated, and it's a complete waste of nutrients, it's a complete waste of energy, it's a complete waste of water, and it produces emissions, for global gas emissions.
It produces emissions all the way through. And when we asked, so in our case in Falmouth, the sludge goes to an incinerator. And we asked, where do the toxic ashes, because by that time when it goes to the incinerator, it's toxic. We asked them, where do those toxic ashes go? Because it's nice to know for everybody where the whole end of this linear system actually ends up, because it ends up somewhere polluting something else. They didn't want to tell us because that's compromised. So we would like to know if anybody knows, or if anybody wants to go after this, we need to know where our waste goes. Because it's not okay for us not to be told where our waste ends up. Because it's toxic waste that probably goes to a landfill, probably in a poor community that needs the money for the landfill, and then it goes in the groundwater and pollutes another system. Because our nutrients, except for nitrogen, a little bit of nitrogen, all the nutrients end up in another watershed. So if we take it out of our watershed, that looks fantastic for Mass DEP, and they're so happy we did the TMDL, but then all those nutrients end up in someone else's backyard. And that's not okay with me, and I need to know where they end up, and all the way through it's climate change.
Can I ask you a question? Earle,
Yeah.
can you get rid of that bar at the bottom? I cannot help it.
No, I don't know how to do it.
I can do it.
Hey, good. So the two solutions that are proposed here in this conference, and which are considered by most towns, are sewers, which are great big nutrient wasting, energy wasting, emissions producing facilities, or IA systems, which are special, basically little sewer systems in your backyard. And they completely destroy your property to put an IA in. They have to bury this big tank in a place where people have been living. They destroy most of the landscape to put it in. They do not include the cost of fixing your landscape up when they give you these numbers in these conferences. They said $48,000 to put in a typical IA. You try removing all the trees first and then patching the thing up and putting your decks back afterwards, and you're up at much more than $100,000 on average. So there's a little bit of a loss of information there in the cost of putting IAs into a landscape. It quit going forward.
Oh, wait a minute. Well, is that all right? Is that?
There, good. So in the watershed planning you see in this conference, they concentrate on the symptom, which is the estuary down by the ocean. They put the sewer down there, when in fact the problem is up in the watershed where all this urine is being put into septic tanks. So we want to put urine diversion upstream on the top of the watershed, take the nitrogen out and not let it get in the groundwater and not go down into the estuary. If you did it that way, you've cleaned up the freshwater ponds and you don't have to sewer down at the estuary. This you've heard before. 80% of the nitrogen in the waste stream is from urine, but only 1% of the volume is the urine. It wastes everything. Sewers and IAs waste everything. The MEP regulations are based on 20-year-old studies, which are all different now. The estuaries are different now. The population is different now. Some of the numbers they used in the estimates at that time were incorrect. They're making 20-year future watershed plans, and you know that the climate's going to change in 20 years. The ocean levels are going to rise in 20 years. The planning has a whole lot of problems and errors in it. So we say divert urine, keep it out of the waste stream. If you keep it out of the waste stream, none of it goes into the groundwater, none of the nitrogen is down in there, does not go through the freshwater pond, and does not pollute the watershed, the estuaries on the ocean side. Some experiments have been done on the Cape. In Falmouth, they did a study of composting toilets. Composting toilets divert urine. The urine isn't collected in a tank. It's not used again as a liquid, but it gets put into the compost in a simple composting toilet and is diverted and kept out of the groundwater. There are composting toilets that divert the urine, shown in this picture, and the urine is collected in a container and is carried off and used in some useful way. In that particular study, Mass DEP did it. 90% of the nitrogen was diverted from the septic tank from this composting system. 99% of the phosphorus was diverted from the septic tank effluent.
That wasn't Mass DEP, it was Mass DEP.
Mass Tech, sorry, not Mass DEP.
Mass DEP was not involved in this study.
And so that's if you use a composting toilet, urine diverting one. If you simply do urine diversion, just take the urine out, you can divert up to 80% of the nitrogen and 55% of the phosphorus if you remove all the urine from a house and don't put it into the groundwater. So there's a difference between urine diversion and pee cycling. Urine diversion is if you simply keep the urine out of the ground. You can do it by collecting it in a tank and carrying it off as a liquid. You can do it by putting it in a compost toilet and have it mixed with the compost so it never gets into the ground. Or you can have an incinerating toilet, which burns it up. The nitrogen is vaporized into the air, but at least it doesn't go down into the ground. Those are all ways to divert the urine from the groundwater. You can also, recycle the urine, which is called pee cycling, in which case the urine is collected as a liquid, usually in a tank. It's carried off, pumped up, and removed periodically. Sometimes it's sterilized, pasteurized, and used for fertilizer on farms. So those are two different ideas. So where do the nutrients from the urine come from? It comes from the food you eat. 460 million pounds of food are trucked onto the Cape every year. People on the Cape eat 460 million pounds of food. 98% of all those nutrients end up in your waste, and 80% of the nitrogen is in the urine. Also, in addition to this food coming over the bridge, 6 million pounds of fertilizer are trucked onto the Cape every year. If you'd collect urine and use it on the Cape to replace some of this imported fertilizer, you've reduced the amount of nitrogen being put onto the Cape in general. So we propose that some of the urine be used to recycle, to replace fertilizers, which are now imported and cause part of the wastewater problem. So what can you do now? We would like towns to immediately allow people to use urine diversion fixtures in their house, if they want to. There are lots of people who would do this tomorrow. They would pay their costs themselves. They would not need subsidies. They would do it for environmental reasons. We want the towns to allow it. We want the DEP to allow it. We would like the Mass Plumbing Board to allow it. None of the fixtures which are permitted, or divert urine now, are permitted by the state. So what are some of these urine diverting fixtures? There's two groups. There's one that just diverts urine as a liquid. There are cubies, which are these little urinals that are portable or unisex. There's in-wall urinals, which we're developing, which is for men only, that divert urine from a bathroom in the wall. It's a little door that opens. You use it, you close the door. 50% of all the nitrogen can be diverted from the Cape with urinals for men in the houses. No house has urinals for men, but they use them everywhere else they go in society. So that's not a great behavioral change. There are sit-down urinals for all people that collect the urine as a liquid. Then there are urine diverting fixtures, which are composting toilets. And there's a wide range of them. They all divert the urine, keep it out of the ground. So what do you do with this urine? In Vermont, they have done this for 10 years. They collect urine, they put it in tanks, either above the ground, in a basement, or buried outside. And if you have urine diverting fixtures in the walls, composting, urine diverting flush toilets, which you can get, the urine is collected as a liquid. In Europe, they're way far advanced from us in doing this. We've done studies on the Cape where we have urine collected in cubies, put in 55-gallon drums. People can have it pumped up and carried off, or they can use it on their own property as fertilizer. In Europe, in France, they have companies that collect urine and turn it into fertilizer for farmers, and that's in the middle. Huge scale of these urine diverting fixtures. And then there are different ways you can store it in containers. You can also safely use urine as a fertilizer on your own property if you use it correctly and if you spread it out in the proper application rate. It can be fertilizer for food production on a home scale, on your own property, on site, using all the urine produced from the people on that site. Rich Earth Institute has developed a machine that sterilizes urine by passing it through a little heater, heats up to 176 degrees for 90 seconds, kills all the pathogens, kills all the viruses. They pasteurize the urine they collect in Vermont, and they give it to farmers. Farmers put it on the hay field, they get twice as much hay. Other farmers put it on cornfields. It's used as a fertilizer to replace commercial chemical fertilizers. We would like to see urine used as composting ingredient to compost with other food materials, food wastes, leaves, landscape waste materials. If you pasteurize urine before you put it into this composter, the material that comes out is safe to use as fertilizer for any purpose. These are commercially made composting devices that are large scale and community scale. A town can have this to recycle their urine and all of their waste organic materials. So one way to get rid of the urine is to simply send it to the sewer, which we don't like because they gas it off and it's wasted. If you sterilize it and give it to farmers, it turns back into food. If you put it into a composting machine, you can have materials, compost produced, which is saleable and movable as a product. So urine diversion has a lot of advantages. It's, you can do it now. It's low tech, it's reliable, it's adaptable, it's flexible, it's environmentally beneficial, it's affordable, and it's less expensive than anything else Mass DEP now allows. So what you can do now is what we think people should do is the town should give subsidies to people to put in urine diversion. They should subsidize it with money or loans or grants. And we think that the town should allow people who do urine diversion to be exempt from the requirement to hook up to sewers or IAs. So it's got many advantages, whoops, there goes. That's the last one. So we would like urine diversion to be another option for towns to use in their wastewater plants that we think would be cheaper and more environmentally beneficial. Go back one. This is a quote. "You have to act as if it were possible to radically transform the world, and you have to do it all the time." This is a radical solution, but it would solve multiple problems at one time.
All right, thank you. So we're going to take some questions now. If you have questions.
Most important.
I think this is the only mic.
That's fine. Because we won't talk at the same
answer
time.
Repeat the question.
Sure.
One of the first graph you showed where traditional sewers are less expensive than using AI systems. Is that in the long run, or is that?
The question has to do with the cost of these things. These numbers are from studies other people have done. This is the cost of centralized building and running a centralized sewer system. And for every pound of nitrogen that sewer deals with and it releases into the air as gas, costs $300 a pound. And all the costs are put in there of building it and running it, as far as I know. The cost for urine diversion is about 1/10 the amount. It's only the cost of pumping it out, transporting it. To sterilize it costs a penny a gallon. A person produces 120 gallons a year. Costs $1.20 in a year for a person to sterilize their urine. Then you truck it off to a farmer who will pay for it. And so the costs are extremely low compared to sewers or IAs.
So the cost of, people say, oh, well, then you have to transport it. and then it's use fossil fuels to transport it. Well, right now we're transporting sludge 70 miles to an incinerator and using all that fossil fuel for that. So when we did our calculations, we used 70 miles. So we can transport our urine 70 miles anywhere that it's needed, and it costs $17 per person per year. Because we only make 120 gallons. If we could collect all our urine that we produce in a whole year, it would be 120 gallons. And then we calculated how many trucks it would take, and it would be about $17 per person per year to truck it 70 miles away to a farmer.
But if I'm doing urine diversion in my regular Title V system, there's still sludge that has to come out every couple of years, right?
Yes, if you do urine diversion in your house, you still have all the water that you produce in your house that has to go to your septic system. You will still have a septic system. If you have a flush toilet in addition to urine diverting fixtures, the solid material from your flush toilet will also go into your normal septic tank. You will have sludge from the normal septic tank, and you still have to maintain the normal septic tank.
So we have a urine diversion composting toilet, so we haven't put any human waste into our system, septic system. So we felt like after the first program 10 years ago, we had it pumped because I was part of the program, and then we hadn't pumped it for 10 years. So we thought we really should pump it and look at it, because we can't just assume. And so they came to pump it, and there was basically nothing in it. And he said, well, we'll see you whenever, maybe 10 years, whenever you just call us, maybe in 10 years. So basically, we are hardly producing any sludge. We also don't have, we don't put any food waste in our sink. So it's only basically laundry and showers and kitchen, dishes.
So the gray water from a house has 10% of the nitrogen from the house.
Hardly any phosphorus anymore, because those phosphates are taken out of our soaps. So there's very little of that. But we reduce it by 99%. So.
Yeah.
When you use your own urine at home, how do you apply it to the garden or trees or?
The urine that we produce in our house, we use as fertilizer in the summer during the growing season. We put it on the soil around vegetables. We put it on the soil of the lawn, or on the lawn. We put it on the ground around trees and shrubs and flower beds. If you spread it out at a rate of 2 pounds of nitrogen per 1,000 square feet, that's a small enough amount that the plants in the soil absorb it. It does not go on down into the groundwater and cause problems. One person produces 8 pounds of nitrogen. You have to spread that out on 4,000 square feet of area. Your average lawn is 4,000 square feet, and the average acre lot is 44,000. So you can distribute it on your own property in a small enough amount, spread out enough that it does not pollute the groundwater where you applied it. You can safely use it on your own from your own family, on your own vegetables without a risk, and the Rich Earth Institute in Vermont has done studies to show that. You could also choose to sequester it in containers for 6 months to be sure all the pathogens are completely gone.
So basically, exposure to the same pathogens in the house with the people that you live in is much more than the exposure you have if you put it on the soil outside and around your vegetables, because you're already exposed to those pathogens. But on a commercial scale, you have to pasteurize, or you can wait for 6 months. In this country, it's 6 months. And the pH goes up really high and basically kills everything within a couple of weeks, but we are supposed to keep it for 6 months. So we have, for a long time, we had dates on every container so that we make sure that it's 6 months. But right now, since they did the research in Rich Earth, we don't wait anymore. We just use it because it's our own vegetables.
Yeah.
Earle, you mentioned earlier that no town had approved these diverting toilets for use. Can you explain why and what needs to be done to see that change?
The question is it true that no town permits any urine diverting fixtures? Mass DEP does not approve any urine diverting fixtures. The Mass Plumbing board does not approve any urine diverting fixtures, and it's because historically urine is not mentioned in Massachusetts regulations. They never thought of it as a separate material. So there's no regulations for it, regulations against it. They just never dealt with it up till now. So that's the current situation.
So you're saying there's no barrier, there's nothing preventing somebody from putting it into their house?
In order to put a fixture in your house, you typically ask a plumber to do it. Plumbers are not permitted to install any fixture that's not on a Mass Plumbing Board list, and there is no urine diverting fixture other than 2 composting toilets and an incinerating toilet on the Mass DEP or Mass Plumbing Board list. So they won't do it. You can buy fixtures yourself and install them yourself, but it's not done in any official method.
Some of these fixtures are being installed.
That person's still taking questions, but I'm just going to do this, okay?
I have
There's a person
I have
wants to
a
have a question. I know.
toilet sitting in my
If
shed
you go over there,
that I'm
I
not
can.
allowed to install.
I see that was a
Yeah.
challenge
Yeah.
or opportunity, that if you're like, so what needs to change to get it so it can be done legally
Yeah.
and in a broader, more acceptable way?
So we have to get a pilot status for our urine diversion.
Installed in Massachusetts legally, so there were 8 in the Ashby. They were only removed because that school turned into a rehab clinic, and the manager said, "I don't trust these dudes to understand the 2-grade toilets." So we put microflush toilets in, and my 2 composting toilets. There are about 4 installed on the Cape informally. It wasn't new construction, they just needed to pull a permit. There was one in new construction in, I would say Orleans, and George Wakefelder from Mass Tech and Barnhart County was part of that. And because they felt unsupported and at the time couldn't get a second toilet, there was a gap in production when the pottery changed, they took that one out and we gave that to someone in Connecticut. But you can, just like in Palo Alto, California, we pulled a special permit. So it's possible that you can get one installed. There's a particular barrier right now to Secavita Ecotech getting them listed, Wolfson toilets listed with the state. And I'm hoping to get around it. But it's not, if we had done this 4 years ago, I think it would be on the state list. It's just, it wasn't an issue, the permits weren't an issue.
So,
Okay, well,
Our time's up.
yeah.
we're